Hello, welcome back to Miss Riley's Maths videos. This is another video about Junior Cert Geometry. Could also be useful for Leaving Cert Ordinary Level, but for Junior Cert Higher Level anyway. And this is the second video of two, so if you've seen the first video and you wanted to keep going, then you're with me. If not, you may have just come across this and hopefully it'll be useful. What I'm looking at is how do we use the geometric facts, the theorems that we know about angles and sides and shapes. How do we use those to answer these questions? So I'm just working through some questions from past papers, and I'll just talk through how I'm coming up with what I'm doing. Okay, so the diagram below shows the rectangle ABCD, ABCD. So we know that this side and this side are equal, and this side and this side are equal. We know that we've got 4 right angles. Okay, A, B and CD are each divided into 5 equal parts. Okay, some of the endpoints of these parts are joined by line segments as shown. So this length here is the same as this length, same as this length, same as this. All of these lengths are the same. Okay. Find the percentage of the area, so percentage of the area of ABCD that is shaded. So we're trying to find out what percentage is taken up by these shapes here. Show all of your working out. So this is a weird shape. We don't have an idea really how to find the area of that shape. So what we'll have to do is find the area of some other shapes that make up that shape. And straight away, the one that I would be thinking of doing is I'd be thinking of that shape. Put in a line there, because what that gives me is it gives me 2 right angle triangles. Okay, and now I can see, well, this triangle here, okay, its area, if I could even just call each of these 1, just to make it easier. If it's easier for you to work in numbers, each of those is 1. So the area of A is a half times the base times the height. So a half times 1 times the height, if this is the height. So a half times 1 times the height, so a half of the height. So h over 2 is the area of A. And the area of that whole bit there would be 2 by h. So the area of the whole BC, let's call that FG, BCFG, the area of the whole of BCFG, BCFG, the area of that whole shape, that rectangle, is going to be 2 by h, so 2h. So we've got h over 2, a half of h, as a percentage of 2h, if I wanted to relate those two. But let's just do the rest of it first. Now, let's call this B. So the area of B is going to be a half by base times height, so a half by 2 times height, so that's going to be 1h. And the area of that whole area, the area of DFGA is going to be 1, 2, 3. 1, 2, 3. It's going to be 3 times h, so 3h. Okay. So if the area of, it looks like I'm going to find the area of the white bit, doesn't it, first, and then I can always find out the area of the whole thing. So the area of the whole, the area of the rectangle DCBA is 1, 2, 3, 4, 5 is 5h, which I can see 2h plus 3h. Okay, and the area of A is h over 2, and the area of B is 1h, so I've got 1.5 h for the white bit. So that means 5 minus 1.5 h is 3.5 h for the shaded. So I've got 3.5 h for the shaded. So we're going to have 3.5 h over the total, which is 5h. So 3.5 over 5 times 100, which is going to be 70% is shaded. Now there's probably an easier way to do that. What would we have done instead? And I suppose we'd have got that in that. 1h, that's right. Maybe we could have split this up, and we could have seen that that was a quarter. That's a quarter, is it? 1, 2, 3, 4. 1/4, and this one would be 1/2 of that. And then another, anyway, it's not too bad what I did. You could have done it another way, I suppose. A would be a quarter of that shape, and B would be, I wonder what it is there. It's 1h compared to 3h, so a third of that one. Okay, and a quarter and a third, you could work that out. So 70% is shaded. I hope that makes sense. Yeah, okay, let's keep going. So the following three terms are used in geometry, so you do need to know that terminology. And a statement that follows easily from a previous statement, a statement that is accepted without proof, and an argument showing that a statement must be true. So a statement that is accepted without proof is an axiom. For example, a straight angle is 180 degrees. That's an axiom. A statement that follows easily from a previous statement would be a corollary. So if this is true, then this must be true. If this is an isosceles triangle with two equal sides, then that means that it's got two equal angles as well at the base. An argument showing that a statement must be true is a proof. Salem writes the following statement: if a shape is a square, then it must have four right angles. Complete the converse of Salem's statement. If a shape has four right angles, well, the converse of that would be, if the shape is four right angles, then it must be a square, but that's not true, is it? Because it could be a rectangle. Is the converse of Salem's statement true or false? It's false, and the justification is it could be a rectangle and not a square. Okay, so it's true that if it's a square, it must have four right angles, but if a shape has four right angles, it could also instead be a rectangle. So that statement, the converse, is not true. Okay, here we are a bit more circle geometry, so let's deal with this, and we're nearly done. We've got a bit of triangle ratios to do after this. The points A, B, C, D are shown on the diagram. They're all on the circle K. AB is equal to AD, and BC is equal to DC. The size of some of the angles are marked. That's 100. Okay, and calculate the value of x. So if we've got a cyclic quadrilateral, okay, then we know that the opposite angles in a cyclic quadrilateral, well, what do we know about them? We know that the opposite angles in a cyclic quadrilateral must add up to 180 degrees. So this angle plus this angle, opposite angles in a cyclic quadrilateral. So cyclic quadrilateral is a four-sided shape that has a circle drawn through the 4 points, okay, at the 4 corners. So add up to 180 degrees, add up to 180 degrees. So that means 100 plus x must be equal to 180 degrees, so x must equal 80 degrees. Okay, and that would be in our circle theorems, which are in chapter 16. So if you're looking for that, it's one of the last circle theorems that we do. I'm just looking up the page number here. Yeah, it's on page 379 of Text and Text 2. Okay, calculate the value of y, showing all your workings out. So y. Now, looking at this, I would say, because they've told us these two sides are the same, hopefully what's jumped to your mind is that that would be an isosceles triangle. If I was to draw a line here, from here to here, I'd have two isosceles triangles. Now notice it's not going through the center, so we can't say that's 90 degrees. If it was going through the center, that would be 90 degrees, but it's not. So how am I going to find y? Well, y is made up of this angle here and of this angle here. Now, this angle here is in this triangle ABD. It's an isosceles triangle, so therefore the angles at the base of those sides are equal, so those two angles are equal. but the whole thing must add up to 180. So ABD must be 180 degrees, the triangle. So what's left is 80 degrees. So this and this together, so two of those must equal 80. So one of those equals 40 degrees. So this angle here is 40 degrees. And hopefully you can do the other one now if you haven't already done it. X is 80 degrees, we proved that here. So again, in triangle BDC, that's 180 degrees, subtract 80 degrees, so 100 degrees, and that's two of those. Again, because that's an isosceles triangle, there's one side and one side, so those two angles are equal. Two of those equals 100 degrees, so one of those equals 50 degrees. So that whole angle is equal to 40 plus 50, which equals 90 degrees, which would mean actually that that must be a diameter. AC must be a diameter. Okay, but they haven't asked us that. Okay. Triangle ratios. The diagram shows the triangle ABC. So this is triangle ratios, I think. The sizes of some of the angles are shown. So this angle, in fact, is shown, and this is 3x and 2x. So if these are parallel lines, these are transversals going through that. This angle and this angle will be the same, won't they? Because they are corresponding. Okay, they are corresponding. So 70 and 70. So now I have a triangle, and I have 3x, 2x, and 70. And they must add up to 180 degrees because it's a triangle. So 5x plus 70 is 180 degrees. So if I subtract 70, 5x is equal to 110 degrees. So x is equal to 22 degrees if I divide by 5. So x is equal to 22 degrees. That would make that angle 44, that angle 66, and we've got 70. If I add all those up, I get 180 degrees. Okay, so that's the first one. The second one, given that AE is equal to 100, so 100, AC is equal to 130, and DE is equal to 74. Find BC. So this is what we're trying to find here. Let's just call that, I don't want to use X because I already used X. Let's call that Y. Okay, now, this is triangle ratios. And in a triangle ratio, just to do a quick recovery here, or a quick lesson, this length by this length, or over this length, is equal to this length divided by this length is equal to this length divided by this length. So it's always big over small, or small over big, depending which way you do it. But you always have to have the big on top and the small underneath. So for instance, if this was the big triangle, was ADE is my big triangle, and then my triangle ABC will be my small. Okay, so aside from the big triangle, that's opposite a particular angle, so that's opposite that angle. Those two angles are the same because these lines are parallel. These angles are the same because those lines are parallel. Okay, so we can say that the big AD divided by the small AB is going to be the same as the big AE divided by the small AC, which is going to be the same as the big DE divided by the small BC. All the sides on the top come from the big triangle, all the sides underneath come from the small triangle. And we could reverse that. We could say AB over AD is equal to AC over AE is equal to BC over DE. And we could also choose parts of sides. So we could also say that AB over BD is equal to AC over CE. So that's another option. Okay. Now, what am I doing here then? I know, what do I have here? I've got that this full size, which is AC, over the small part, AE, is going to be the same as the big side. So this is one full side of this triangle here over one full side of this triangle. That's going to be the same as this side, one full side of the big triangle over the corresponding, is the word we use, side of the small triangle. So that's, sorry, y over, so let's just call it BC over DE. So AC is 130 divided by AE, which is 100, is going to be the same as BC, which is y, over DE, which is 74. Okay, so now I've got, let's just change that round so that the y is on top left. So I'm going to multiply both sides by 74. So y is equal to 130 times 74 over 100. 130 times 74 equals, divided by 100, equals 96.2. So y is equal to 96.2. So 96.2 over 74 equals 1.3, 13.10, 13 over 10. And 130 divided by 100 also equals 13 over 10. So that ratio is the same. So y is 96.2, and that's what BC is. It's 96.2. Okay. And then finally, in the diagram below, MNP is equal to P or Q. So M and MNP is equal to P or Q. Okay, so if those two angles are equal, that looks like those two are parallel then, doesn't it? Because that would be our Z angle. Okay, or I didn't do that, I should do it the other way. This one and this one are the same. Okay, so they're going to ask us that in a minute. Prove that MNP and QRP are similar. So MNP is equal to P or Q. This angle here and this angle here are equal to each other because they're vertically opposite. So NPM is equal to QP or, because they're vertically opposite. And that must mean that this angle and this angle are equal. So angle PQ or is equal to angle NMP, because they're the third angle in a triangle. Okay, so similar triangles as equiangular. So we're given that, just to put in there, we were given that MNP is equal to P or Q. That was given to us. Okay, is NM parallel to QR? Yes, as angle NP is equal to angle N or Q, alternate angles. Given that MN is equal to 6, so let's just draw this again. I'm actually going to draw MNP, Q, or I'm actually going to redraw these so they are looking a bit more like each other. Just going to flip that one down, so that's PMN, and then the bigger one is going to be PQ, or this angle and this angle are the same, and this angle and this angle are the same. Sorry, I've changed my symbols, which isn't helpful, but sorry. So these two angles are the same. So this is here, this is here, and this is here, this is here, this is here, and this is here. Okay, so these two triangles are similar to each other. They have the same angles. Now what do I know? I know that MN is equal to 6, NP is equal to 4, and QP is equal to 9. So find, and POR is equal to 10. POR is equal to 10. And I've got to find QOR. Okay, so Picking the sides that are opposite the same angles. I'm trying to find this one. Let's call that x. So x over 6, that's the same, they're both opposite the square, is equal to 1 from this one. So opposite the dot is equal to 10, and the 4 is opposite the dot, 10 over 4. Okay, so always find corresponding sides. So that means if I multiply both sides by 6, I get x is equal to 6 by 10 over 4, so x equals 15. So QR is equal to 15. Okay, this side now is equal to 15. Find QM. QM, that's the whole of that. Okay, so to find the whole of that length, I need to find this bit and this bit. Okay, so I know QP is 9, so QM is equal to QP plus PM. QP is 9, and PM I haven't got. So let's call that Y. And we're trying to find it. So we have PQR. So PM is that one there. It's opposite the asterisk. So PM, sorry, this is 4 and this is 6. PM is Y. Y over the side opposite the asterisk is this one. Y over 9 is equal to, what do I have? Oh, well, I have 6 over 15, don't I? Or I could have 4 over 10, because they're both opposite the dot. That's with that, and that's with that. So 4 over 10. So multiply both sides by 9. So y is equal to 4 times 9 over 10, which is 36 over 10, which equals 3.6. So the length y, which is PM, is 3.6. So the length QM is equal to QP plus PM is equal to 9 plus 3.6, which equals to 12.6. Okay, hope that made sense, and take care and talk soon. Bye-bye.